So, Vanakkam, we will continue our lecture on engineering seismology. So, we have been discussing about the zonation. Okay, so we understand that the primary importance of the zonation is basically to give input for the building and infrastructure design. Okay, so that input will be like your acceleration time history. So, like this, whatever earthquake representing. Okay, so or you will get a the spectrum. Okay, so the design spectrum. So these are all the two input which is generally given from the most of the maps. Okay, so this can be represented as a PGA, okay, or PGV. Okay, so depends upon the structure we can take. The primary objective of this zonation is to provide information. Okay, so the provide data for the building design. That is what the first and foremost primary objective of the this zonation mapping. So depends upon the this parameter scale and the consideration, the maps can be vary. So we have seen that macro zonation map, which is basically goes for the very large level of area, okay, like continental, okay, so the Asia, okay, so South America, North America, like that continental wise mapping and zoning hazard is the macro zonation. The micro zonation is actually varying the regional level variation, particularly accounting the soil variation in the region, which is responsible for the wave modification, and then the soil failure such as a liquefaction and a landslide. So capturing of this variation can be done at a micro level, that is a microzonation. As we have seen that even though the microzonation and zonation map well advanced in several countries, it was not well established in India. Okay. So we have seen some of the microzonation study which has done a particular type of study, not all the component of microzonation which I discussed as a methodology, and claimed that as a microzonation. So such as issues can be overcome when you do the systematic preparation of microzonation maps. As I told you that as on now we have the microzonation map only for the few cities, which is like more reliable and good map. Okay, so like Bangalore microzonation map, one of the example you can say, and then Guwahati microzonation map, Jabalpur microzonation map, and then the Delhi microzonation map. So the Delhi will be the more advanced than the any other this one, because it was done by the 2-3 times with a different group of people considering the all the aspect. Okay. The Bangalore microzonation, of course, it has been outdated, as we discussed that any seismic zonation map has to be updated every 4 to 5 years or soon after the major earthquake, whichever is earlier. Okay. But Bangalore, we have done this microzonation around 2008, something like that. The project was completed. So now we actually almost like 12 years old, still it is not updated. And moreover, the microzonation, okay, of the Bangalore done only for the old BBMP area of 650 square kilometer, not for the present city, which is actually extend up to I think close to 1000 and above square kilometer area. So which needs to be updated. So it's not that whenever we prepare a map and leave it as such, as we have seen in the global earthquake modeling, they said that these maps they will be keep updating frequently whenever there is a changes in the model, changes in the data. So unfortunately none of the Indian microzonation map which is developed as a this kind of update possibilities. Okay, so when you use that open Quack software system in the GEM, which may be possible to get those kind of update frequently. Okay, so that kind of map is a more reliable and updatable frequently. That is what we should target. Okay, that kind of microzonation map. So the more objective, the first primary objective is to provide your input data. Basically, we will be giving the data of the design values for this one. So that is one of the main objective of this microzonation. The second is this microzonation map also can be used for the city planning. Okay, so the development and investment and any kind of knowing the seismic risk and vulnerability. How many people will die, how much economical loss will happen if this kind of earthquakes are coming, where it will happen more, where it happen less, such kind of study and understanding, okay, the disaster management, planning, okay, so all those things are required this kind of microzonation map. So, okay, so as I said that the microzonation map is primary objectives to give the design parameter for a normal building design in the region. So, let us see what is the design parameters are recommended from Indian seismic code. So, the guideline which is given from this kind of study is given in the form of codes and standard on each country. Let us see how our Indian code gives this parameter since its origin to as on now, how these values are representable. Okay. So, the seismic code, okay, the Indian seismic code we are going to discuss in detail today. So, I will be telling the each and every aspect of the code. So, I am not criticizing the code too much, but I am trying to say that it needs to be updated. Okay, that is what the important message you should get. Or when you are constructing something, you should also think what is the state of art knowledge gone to the codal development, so that you appropriately take decision, particularly the important buildings. Because the small buildings like ground floors 1 or the ground floors 2 building collapse, only 1 or 2 people or 5-6 people die. The apartments like 1000 family and 5000 family apartments and all constructed based on this kind of code. Okay, so many people will die if the values are taken is not appropriate. So, after reviewing the code yourself, you will see that the values are how representative with the state of art knowledge what we discussed earlier or what we are going to discuss in the future classes. So, the macro zonation, our code actually is a macro zonation, it is not a micro level, because the information gone into the code development was only geology and seismicity. Okay. So, as you know that when we are talking about the plate tectonics and types of plate and all, so we discussed that the India has the majorly 2 classification. One is that the plate boundary, which takes care of the northeastern and northwestern part of India. Okay. So, where there is a regular distribution of the earthquake. So, there is a frequent distribution of the or frequent occurrence of the earthquake in the region, where which is called as a northeastern, northwestern part of India. The another one is actually the peninsular India, okay, which is irregular distribution of the earthquake, okay, which falls middle of the Indian plate. Okay, that is so the earthquakes in peninsular India are intraplate earthquake in nature, because the peninsular India itself far away from the plate boundary as per your types of earthquake definition. If you see, these are all the intraplate earthquake. So, the earthquakes in the other part, okay, the northern part, okay, northeastern part, northwestern part, interplate earthquake, these regions are very close to the plate boundary, but there are some earthquake which is occur away from the plate boundary, as we have seen that 10 km away from the plate boundary region is considered as a basically the intra-plate earthquake. So, the intra and interplate earthquakes are possible in the northern part of India. Okay. So, both northern part means I am starting with respect to the Delhi, Haryana, UP, Bihar. Okay. So, this Nepal region, Uttarakhand. Okay. So, then the Sikkim. So, this side Tripura, and then the Manipur, Meghalaya, and this Jammu and Kashmir. So, these are all the region I am talking about here. More inter and intraplate earthquakes are possible. So, there are several attempts has been made by the scientists to study the earthquake hazard. So, the first attempt made for the assessment of the seismicity and the earthquake hazard by the Khatri. Okay, he was the first person to work on the seismic this one. Okay, so then the Billam 1997, Verma. Okay, so then the Khatri and Toy. So, the Billam and Verma and all, they carried out some kind of seismicity study, but not hazard analysis. Khatri work was the first one. So, then there are many people spend their time on try to describe a seismotectonic, seismology and seismic hazard, including my own research group. Okay, so this is the our work actually. So these are all the people who overall contributed to the hazard analysis of the different part of India. So even here Nathan Timbajam, this was missing actually. This was updated on 2009, the 2012. Okay, so Nathan Timbajam work and other people work. Okay, so these are all the some of the example. You can get more details about this work in the website. Okay, if we type hazard analysis in India, so you can get list of papers which is published together as on this one. So as I told you that there are group of scientists, they work, take a procedure, apply to particular region and produce a result. Okay, without knowing that that particular procedure or without worrying that the particular procedures are applicable or non-applicable. So those kind of like application direct to oriented studies also you can find. There are people who do research on each and every aspect of the hazard analysis. Okay, so our group we do research on hazard analysis. Okay, so why we should estimate Mmax this method, why we should estimate magnitude conversion this method, homogenization this method, why we should estimate use this GMP. Okay, why I should consider this source. Such kind of questions are asked in our research. We try to address that and overcome some of the limitations in the common hazard analysis procedure and try to incorporate, update a procedure as per the regional data. We call it as a regional rupture based seismic hazard analysis, which we also published a couple of papers on that. Those kind of research, okay, on the hazard analysis, site response studies, liquefaction assessment and amplification study, that is what we do part of my teaching and research at IISc, which you can see from my publication. Okay, anything which somewhere developed I don't take as such, as we have seen that some of the maps are produced from the GMPs developed elsewhere without knowing that the GMP is applicable or not. So when I do my work, I actually study those things, assess the reliability and try to incorporate most representative results. Okay, so there are, as I told you, that the two group of scientists work like that. One group of scientists simply take the typical methodology or procedure which is adapted universally or anywhere in the world and adapt same thing to India without knowing a complex and the geology and regional variation. Okay, so that kind of study will be more or less, you can say, approximate. Okay, you can expect more reliable results. So but when you try to take a procedure and methodology and try to see that how it can be adapted to your region, how it can be suitable to your region, what are the way you can incorporate your regional level parameters to account, okay, the regional variation, seismicity, then that kind of study will be more representative. I work on second category actually. Okay, the rest of the category work you can see lot of papers on that, but you have to be very cautious. Why I am telling that, when you read about the papers, okay, whose paper you are reading also very important. Okay, who has published that paper also very important. Not all the paper, see everybody give you a hazard map. When you look at as a hazard map, you can see most of them are given a hazard map. Which hazard map is more reliable, which hazard map is less reliable, that depends upon the what is the input and model gone to prepare that hazard. Okay, so that you have to keep it in mind. Otherwise, you will be ending up in the referring a wrong paper, okay, and wrong equations, wrong result, which will lead to a problem. Even though you design, if you consider a wrong input, your design may not be sustainable or may not withstand a load what you are considering. So the wide variation of amplitude of ground motion and frequency of occurrence of occurrence of earthquake is possible in India because you have the very active plate boundary, you also have the stable region. Okay, so there is need to divide the India into broader zone based on the expected ground motion to represent a seismic hazard at each part of the India. Okay, so that is how the zonation importance, okay, can be understood. So this was evinced by the Geological Survey of India, okay, GSI, and developed a first seismic hazard map of India in 1935, okay, after Bihar Nepal earthquake. So this was the After 1934 Bihar Nepal earthquake, many people have died. So which made the British government to think that we should give a consideration about the developing a national seismic hazard map which shows a possible hazard at a different part of India, which will be useful for design of building. Okay. So which was done, and then this was developed, and the committee has been formed, people has worked on that and produced the seismic hazard map. But unfortunately that map was not published at that time, whatever is generated. Okay, in 1947, okay, after independence, the Indian Standard Institute ISI has been formed, okay, was established to set up standard for the industrial and commercial product. Later it was named as a Bureau of Indian Standard BIS under Bureau of Indian Standard Act, which formed, standardize, certify, manage quality of various product. Okay, that is what ISI and BSI does. So BSI cover wide range of industry, consumer organization, scientific and research institute, central ministries, regulatory authority and educational organization. So the BIS is official agency responsible for producing and publishing a seismic hazard and codes in India, which is accepted by all over other national agencies. So the basically the BIS is a responsible agency who is responsible for the current seismic hazard map of India. Okay. So the BIS is they are the agency who should revise, update and publish a map on interval basis. Okay. That is what BIS should do. So with the BIS guidance, okay, so there is a code, okay, named as a IS 1843, the part 1, okay, is the seismic official code of country. So this code gives the information for the building design, for the normal building. Okay. So normal building design, this code produces. So the current version of this code is actually 2016. Okay. So the part 1 is I am specifically because this is more suitable for the residential building. For other buildings there is a other part. So we are only going to discuss about the part 1. So the committee has considered earthquake zoning map based on the maximum intensity at each location as recorded damage survey after the past earthquake, taking into account of the. So this IS code given the following statement in the code which describe how the code was developed. Okay. The committee has considered an earthquake zoning map based on the maximum intensities at each locations as recorded from the damage survey after the past earthquake, taking into account of the known magnitude, known epicenter, assuming all other conditions are being average. Okay. Then the tectonic and lithology of the each region. Okay. The seismic zone map broadly associated with 1964 MSK intensity scale corresponding to 6, 7, 8, 9 for the seismic zone 2, 3, 4 and 5. So from here you can understand that the past earthquake damage data has been collected and people taken intensity as a reference value and then they prepared a zonation map. Okay. So that was written in the code, which was not my statement, which was explicitly written in the IS code. So it is not intended this standard to lay down a regulation so that no structure shall suffer any damage during a magnitude. So this code objective is to not to give you the value which will completely save, okay, structure. So it is not intended this standard to lay down regulation such that no structure shall suffer any damage during an earthquake. That means if you consider this codal values for the design, if earthquake comes you may expect some damage, but it may not collapse, okay, so that you can escape and save your life. That was the motive and the definition given in the code. So it has been endeavored to ensure that as far as possible structures are able to respond without structural damage to the shock's moderate intensity, without total collapse to the shock heavy intensity. So this was the consideration gone into the development of zonation map. So while this standard is intended for the earthquake resistant design of normal structure, it has been emphasized that in the case of special structures such as a large, tall dams, large span bridges, major industry project, site specific investigation should be undertaken unless otherwise specified in the relevant classes. So that means whenever you have a special buildings, bridges, okay, industrial buildings, you need to get site specific studies done. The values given in the code may not be suitable. Okay, that is what message conveyed from the code. So the earthquake can cause damage not only on account of the shaking which result from them, but also due to other chain of effect such as a landslide, tsunami and fire disturbance to the communication. Okay, so these are all the where it can cause a hazard. Okay, so this hazard is not explicitly considered in the present code. Okay, so it is therefore important to take necessary precaution of the siting, planning, design of structures such that the safe against the secondary effect also. So you can need to consider when you do this kind the control, loss of life property, base isolation, other advanced technique may be adopted. Currently the Indian standard under a formation for the design such building. Until the standard becomes available, specialized literature should be consulted for the design. They say that you should adopt a proper methodology of design to basically design your structures which can save from the any future earthquake. So this was the guideline given in the IS code, beginning of the code, forward page it has been given. So the first seismic Indian code. Okay. So in 1962, okay, the BIS published the seismic zonation map of India based on the earthquake epicenters and isosysmal map produced by GSI in 1935. You can see. So the whatever work done in 1935, it has been only republished and published the first seismic zonation map. Okay. So you can see the different zones here. The earthquake magnitude 5 and above with the maximum modified Macaulay intensity ranging from 5 to 9 was considered. India was divided into 7 zones ranging from 0 like no damage zone and 6 is the extensive zone. You can see the 0 damaging zone. So these are all the 0 damaging zone. You can also see the higher zone. You can see here higher zone which is basically the extensive damage expected region. You can see here also 0. Okay, this was the first seismic zonation map of India published in 1962 under BIS, considering the work carried out by GSI on under 1935. So the Deccan Plateau was considered more or less safe zone and the hazard value was assigned as a 0. That is what you can see. While a larger part of northern India was assigned the zone 6. Okay, you can see the so these are all the highest seismic zone. You can see the Bhuj. Okay. So the zoning was reviewed in 1966 and the additional information like geology and the tectonic features were taken into account for modification of the zone. So with more weightage being assigned to the tectonic maps and that delineates the fault. So the 1962 and 1966 BIS zonation map have 7 zones. Each zone were assigned a maximum MMI scale of intensity historically observed or expected intensity of the particular region. Okay, this is the 1962 map. There was about 7 zone. Okay, this 7 zone was actually adapted in the old BIS code, a first version kind of things, where you can see the maximum probable intensities expected on each 7 zone. You can see seismic zone and comparatively the probable maximum intensities on the each zone. So, this was the first map produced by the GSI and officially released by the Government of India, Geological Survey of India, where these maps are been given as a map for any seismic design in the country. Okay, that is what they have done. So, this map where the respective, you can see that the intensity of 10 and above assigned for the seismic zone 6. Okay. So, where the intensity of below 5 has been assigned for the zone of 0. Okay. So, even though seismic zone 0 means it does not indicate that there is no seismic activity, it is only indicate that it is corresponding to the intensity of 5, okay, expected in the region, that is what it indicates. So, after this map, okay, so in 7 seismic zone based on 96 was expected to maximum MMI. Okay, the zone map underwent a major revision in 1970s after 1967 Koina earthquake, which we have discussed that Koina has a reservoir induced earthquake. So, where the Koina is located on the Deccan Plateau, by which the assigned zone 0, no seismic activity as on that paper published. So, 1970 the map was been updated, okay, considering this aspect. That map basically seismic zonation map of the 1970s. So, there are highlights that includes the both geological and geophysical data in the zonation and the removal of zone 0 as scientifically reason with no seismicity cannot exist. So, we have seen that the 0 zone, the Koina earthquake was there. So, that means there is no point in putting 0 zone even though the intensity 5 and above is expected. So, that 0 zone has been removed. Therefore, the zonation reduced to 5 to 5. So, 0 is removed and then 4 and 5 are merged old zone. So, instead of 7 zone it become a 5 seismic zone of the steady region or India. Each zone assigned a probable intensity values. Okay, so, based on this one, then the upgraded map placed, okay, Koina around zone 4. You can see that Koina earlier it was in the zone 0. See. Okay, so, this major modification done in 1970, okay, PAS version. So, that was the third version of the code, okay, where they have developed a map and included Koina earthquake after this. So, that means the zonation map underwent a major revision soon after the Koina earthquake. Okay, that is what the message you take it from here. So, right now we discussed about the seismic zonation mapping and seismic zonation. We discussed the first seismic zonation map and second seismic zonation map. So, both of them, and this map will give you the idea about how the seismic zonation changes in our country. So, with this we will close this lecture. So, we will continue our lecture in the next class. Next class we will discuss about the next version of the seismic code, okay, and finally end up in that how the today code, what are the values and implementation of the today code we will be discussing in the next class. So, thank you very much for watching this video. We will see you in the next class. Thank you.